to the Section 2.1 lecture video. The topic today is frequency distributions and their graphs. A frequency distribution, or a table, just lists what we call classes and the number of data values in each class. In this example, you can see that the word interval has been used instead. Most folks, though, do use the word class. The frequency of a class is just the number of data entries in this class. So I've presented you with a table of values. This table represents the age of lottery winners. So you can see ages going across the bottom, and they're divided into different intervals we call classes. And then the number of winners, it determines the height of the bar. So theoretically, I would have had a list of data that said, here are the ages of lottery winners. So there'd be like a 26 and a 22 and maybe a 73, etc. And you would go through and put a tally mark in this column for each age and the interval it belongs in. We're going to do that in the example, but you've probably seen that before. Before we do our example, though, I want to get a couple of definitions out of the way. The first blank here, a blank is a category or interval that contains data. That's the word class. And an example from above here would be like 20 to 29 is a class, okay? Any of these in the interval column are classes. The lower class limit is the smallest number that belongs to a class. So if we're talking about this class that I chose for my example, 20 to 29, we call the 20 the lower class limit, the smallest number in that class. And then similarly, the upper class limit is the highest number that belongs to a class. In this example, 29 is the highest piece of data we would find in this class. The class width is what we call the difference between two consecutive lower class limits. So in this case, you have to have two consecutive, one after the other, classes. So I would take, for instance, 20 to 29 is a class, and the next consecutive class would be 30 to 39. The class width is defined as being the difference between these two consecutive lower class limits. And difference really does mean subtraction. So you would take the larger number 30, subtract the lower number 20, and that gives you 10, and 10 is my class width. Now, what that actually is telling you is how many pieces of data could possibly fit in each interval. So for instance, when we say 70 to 79, students are tempted to think, oh, there's 9 numbers from 70 to 79. But if you actually count it out on your fingers, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, there are 10 numbers. So that's what the class width is calculating, is the number of pieces of data that could potentially fall in that class. And the last bit of vocabulary we call the range, the difference between the maximum and minimum values in the data. Now, in this example, because I didn't give you the list of data, you actually can't determine the range. You can't assume that 79 did appear in the data list and use that as your max, and 20 appeared and that was your lowest. You don't know that. So for this example, it's not possible. To compute, we need the raw data. But never fear, we're going to do an example where we will be able to calculate it. All right, so to construct one of these frequency distributions, which is what we call this table, these are the steps to construct a frequency distribution. Now, I'm going to assume you are capable of pausing the video and reading through them. I'm going to go ahead and we're going to do each of these steps with an example. This example 1 is found in your textbook. The data set here is the out-of-pocket prescription medicine expenses in dollars for 30 US adults in a recent year. We're asked to construct a frequency distribution that has 7 classes, and that's the important piece of information. Most often you will be told this number. So notice the first step in the process is determine the number of classes that was given to us, and we're supposed to make 7 classes. To calculate what our class width should be, now the last example, it was 10. It could be 5, it could be 12. It really depends on your data set. So to help you decide, should you put 10 numbers in a class, 12 numbers, 14, 20? You use this formula. And use the formula, you're probably going to get a decimal. So you just round that up to a convenient number. Okay? So we're supposed to take the class range and divide it by the number of classes we want to use. Class range, remember, is the difference from the highest to lowest. This is the one we couldn't calculate in the previous example. So you scan through the list of data looking for the largest, which I believe is right here, the 405. And then you look for the smallest piece of data that shows up in the list, which is here, which is 155. So we will subtract those to calculate the class range, 405 minus 155, and we're going to divide that by our number of classes, which is 7. So in the numerator, this turns out to be 250. The denominator is 7. Now, just a note about calculators. You should have a calculator handy for this course. Graphing calculators fine, scientific calculators are fine, anything like that. You can use your phone, of course, if you're just doing homework, but on any exams, you would need to have a calculating device. So make sure you have one. And when you type that in, you're going to get approximately the number 35.7. Now, obviously, if we're talking about how many pieces of data are in a class, I don't want there to be 35.7 of them. That's inconvenient. So I'm going to round that up to 36, and that's my class width. All right, now it says choose either the minimum data value or a convenient value below it to be the first lower class limit. What does that mean? Well, my lowest number is 155, and that's kind of a decent number. You know, it ends in a 5. If your number was something like 121, you might actually want to make it 120 just to have it be nice round numbers. So that's kind of a judgment call. Like I said, since this one ends on a 5, I'm going to go ahead and say that that's going to work for us okay. All right, so 155 is going to be my first lower class limit. I'm going to go down to my table now and start setting up the class limits. So the first one will begin at 155. Now it's supposed to have 36 pieces of data. You don't need to bother going through and like counting off what number does that end with. What we're going to do, as it says in step 4, is find all of the lower class limits. So I'm just going to add whatever my class width was, which was 36, onto my previous lower class limit to get the next one. So 155 plus 36 is 191. Then you take 191, you again add your class width, you're going to get 227, and you continue the process. I'm going to go ahead and fill those in. All right, I finished doing that and I stopped at 371 because I wanted 7 classes. So as soon as I get to the 7th class, I stop. Now the next step, step 5, says fill in the upper class limits. So how do I know those? Well, classes are not allowed to overlap. So if the second class is supposed to begin at 191, the previous class had to stop at 190. Same thing for the next one. Look ahead. The next lower class limit is 227, so the previous one would have had to stop at 226, one number before. I'm going to go ahead and finish filling in the upper class limits. All right, I have finished that job. And the last step is simply to tally the data now and count the data. So this is where you would go back to your original list of data and go one by one, finding a score and putting it into the proper class. So the first piece of data is 200. I'm going to cross it off so I know that I've tallied it. And 200 falls between 191 and 226. So I put a tally mark there. I go back up to my data. The next number is 239. Where does 239 fall? In the third class. Put down a tally mark. 155 is the lowest, so that's in the first class. And you would go through and finish checking off all 30 pieces of data. I'm going to pause the video and come back when that is done. Okay, so here are all of my tally marks. You can see I did use the convention where when I get to the fifth tally, I kind of bundle those tally marks together so that it makes it easier to count. And that's the last step. I'm going to count the data, and that count is the frequency. And we use the abbreviation F to stand for frequency. So I count my tallies. There are 3 pieces of data in the first class, then 2, 5, 6, 7, 4, and 3. It's very simple to make a mistake when you're doing the tallies. So as sort of a check for that, what we're going to do is we're going to sum up this frequency column. This thing that I just wrote here is the Greek letter sigma, and in mathematics, it's used to represent a sum, a totaling up. So I'm going to total up my frequency values, and if I add 3 and 2, 5 and 6, 7 and 4, and 3, I get 30. That at least confirms that I tallied all of the numbers because there were 30 pieces of data in this data set. So that's the first thing you need to be capable of doing, is constructing one of these tables for yourself. Next, we're going to move on to how we can kind of enhance our table to give us more information about our data.